Drake equation is an expression by a scientist named Drake. He wrote this in 1961 to calculate how many what you could call actively communicating civilizations there are. And you can see that there's n, the number of civilizations with which humans could communicate, is equal to a number of things. One is the mean rate of star formation. Another is the fraction of stars that have planets. Another is the mean number of planets that could support life. Another is the fraction of life-supporting planets that actually have life. Another is the fraction of planets with life where life develops intelligence. Another is the fraction of intelligent civilizations that develop ability to communicate, like we have. And then finally, the mean length of the time that civilizations exist and can communicate. We're in an experiment to see how long that's going to go. So that's the Drake equation. It's a simple number of terms. All you have to do is plug in the right numbers in there, and you'll come up with the right answer for the number of actively communicating civilizations in our galaxy. The Fermi Paradox is basically a challenge by Enrico Fermi, a very famous physicist, who said, where are they? And the Drake equation, if you plug in most people's numbers, it comes up with a very large number for the actively communicating civilizations in the galaxy. And Fermi said, okay, there's lots of them out there. Where are they? And basically the paradox is, Drake equation calculates lots and lots and lots of actively communicating civilizations. Fermi Paradox says, but we don't see any evidence for any of them. So that's basically it. An exoplanet is one of the most exciting scientific developments of my lifetime. That is, we have a sun, and that sun is a star, and we know that there are planets orbiting that star. And the likelihood is that there are other stars in the billions and billions of stars in our galaxy that also have planets. So an exoplanet is one of those planets that's orbiting another star in our galaxy. Or they could be in other galaxies, but we can't see them. And in 1995, astronomers were able to see the first one. And it's a very exciting field, how they were able to see the small planets are very small compared to the stars that they orbit. But since that time, astronomers have discovered over 5,000 exoplanets, and there are many, 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 many more out there. So interest now, a very wide range of scientists and the public is, okay, we know there are exoplanets. Now we can start putting in some numbers into one of the terms for the Drake equation. Still, it doesn't change the fact that nobody's tried to get in touch with us, according to reliable reports. One might wonder why a geoscientist like myself would have anything to say about exoplanets, the Drake equation, and the Fermi Paradox. But the reality is there is no planet that we know better than our own. And we have life, and we have continents and oceans, and we have plate tectonics. So in some of my studies, I've been working on the question of when did plate tectonics start on Earth? So plate tectonics is the fact that Earth's outer shell is called the lithosphere. Most people know about the crust. The lithosphere is slightly different, a little bit thicker than the crust, but basically the same. So the lithosphere is broken up into a number of fragments we call plates, and those plates are all moving independently. Some are moving towards each other, some are moving away from each other, some are sliding by each other. But plate tectonics is this world where the planet's surface is broken up into these fragments that move independently. So plate tectonics provides an interesting perspective on life. What is the relationship between our advanced communicative civilization and the fact that Earth has plate tectonics? That is a question that hadn't really been addressed before we wrote this paper. Okay, so what we did in our paper was, which is called the Importance of Continents, Oceans, and Plate Tectonics for the Evolution of Complex Life, Implications for Finding Extraterrestrial Civilizations. It's in Scientific Reports, which you can download for free anywhere. But basically, what we found was, okay, there's one term in the Fermi Paradox that isn't completely constrained, and we think we can constrain it better. And that is the fraction of planets with intelligent life that will evolve to communicating advanced civilization like our own. And you might say, well, aren't they the same? And the answer is no. There are many intelligent creatures on Earth. There are elephants, there are whales, there are dolphins, there are octopi. They may be more intelligent than we are, but they don't have our unique ability to take what used to be our forelegs, which have now evolved into hands, which can make tools of all kinds and do things. In order to do that, you really need to be on land. The reason a whale or a dolphin or an octopus would never invent radio waves or a rocket ship is it's unimaginable, right? You're not going to need, you're not going to know how to evolve from making stone tools to making wood tools to all of the things that humans have done. One of the most important was the invention of electricity. That could never happen underwater because, water is such a good conductor of electricity. You need to be up on dry land. Rocket ships, we can go back to the sea now and launch rocket ships in submarines, but the reality is you're not going to invent a rocket ship if you're completely living in the ocean. So you have to do two things. Life has to begin, which it obviously did on Earth, about 4 billion years ago. And it has to evolve most of the way in the oceans. So the complex life in Earth evolved to the point of seashells and fish and things like that. But it didn't climb out of the land until about 400 million years ago. And from that point on, there has been at least one species that developed these special tools that are necessary for developing an advanced communicative civilization. Hands, technology, electricity, fire, all of the things that we now take for granted. So unless you have both continents and oceans for life to begin and to do most of its evolution, and land for something to come out of the ocean and evolve into something that looks up at the sky and wonders and is able to make rocket ships and radio transmitters, there's no possibility. There could be billions of exoplanets with life in our galaxy, but no advanced communicative civilizations. The question is, which of those planets have both oceans and continents and life and plate tectonics? Now, I've explained to you why oceans and continents are so important, but why is plate tectonics so important? Well, plate tectonics accelerates evolution. So there is another style of planetary tectonics, and it's called single lid, and that means that nothing's moving around. It might be moving up or down. There's eruptions, there's earthquakes, but nothing is really changing. So what happens on plate tectonics, because the plates have the continents, they're colliding into each other, they're breaking apart, they're moving north and south, east and west, and that creates new habitats where complex life is forced to adapt. You can be a very successful creature in the tropics, but if for some reason the plate that you're on goes to the polar region, you're going to have to change and adapt. And that's what happened with human beings. We had a very successful group of primates in Africa. They were starting to play around with stone tools and learning how to kill each other like we're so good at. And then we came out of Africa, and in moving across all of the continents, we evolved in a way, our technology evolved in very interesting ways. Plate tectonic accelerates evolution, and it does that not just by having the continents move around, but also because plate tectonics generates mountains. It provides a nutrient flux to the oceans that doesn't exist on single lid planets, even the ones that might have continents and oceans. And that nutrient flux, that subtle, constantly changing environmental pressure, those things accelerate evolution. And so plate tectonics is very, very important in terms of having the conditions right for evolving advanced communicating civilizations. It's those three conditions. Number one, you have to have life. There's no way you can evolve an advanced life without having some life. Number two, you've got to have continents or oceans, the oceans for life to begin and to evolve most of the way, and then dry land for them to climb out of. And plate tectonics has to be moving that dry land around. I mean, there's a number of you can't predict, whether this will have any impact on science in the future. We hope it does. My colleague and I, Taras Gurya at ETH in Switzerland, and some other people have started a new transdisciplinary field called biogeodynamics. And biogeodynamics is looking at how the behavior of the solid Earth or the solid of any planet will affect the evolution of life on it. Biogeodynamics. Well, obviously, the earth sciences have been very good to me. I think that getting the foundation in earth sciences and understanding something about evolution is the best way to prepare for opportunities. Just get an education and be willing to listen and think about other things than maybe just what pays the bills.
Thank you.
Sure, my pleasure.